Good morning, everyone. Good morning. Welcome back. Welcome to our day 4, our last day of theory. We still have one more day to go. Remember, we still have our exam preparation class tomorrow. But today we have our last day of theory, folks. Thank you again for joining. Let me get my screen here. In the meantime, folks, a couple of announcements. You know, I like to start with announcements. First of all, sorry about the inconvenience we had yesterday. We're expecting to have completely out of inconveniences today, so we hope for the best. And second, about the videos, the extra material and stuff. Well, I was requested explicitly by Microsoft to share that until the last day. So again, I have already uploaded the videos and the solutions. So you'll be able to have access to those tomorrow. Okay, I'll be sharing those links tomorrow at the beginning of the day before we start with the exam preparation, folks. Give me 1 second. Let me see here because I'm having a thing from my drive. What I want to check is that we have everything ready. And you should be seeing the screen popping in the next couple of seconds. So there it is. It should be loading on your end and should be ready by now. So we have 2 final topics today, folks. We have networking and we have a short topic, pretty short, about business continuity and disaster recovery. Basically, is um, the recovery service vault. It's pretty small, but pretty important. So this is the expectation of the day, folks. First of all, let's start with the network, and let's talk about a few things that we can configure when we refer to the network. Okay, what we have on this lesson, folks, we're going to talk about some solutions, some requirements, some best practices for the network configuration. Okay, then we will see a couple of tips about how to connect or how to create an on-premises hybrid solution based on the virtual network we have in Azure, plus the networks we might already have on premises. We will talk about connectivity services, options we have to leverage the network in cloud. And finally, we will see about delivery and protection. We will talk about those 2 topics to wrap up our day. Okay, so this is what we have for today's session, folks. Well, for the first half at least. The second half is about business continuity, as I said. So let's get started first with the basic solutions of network. Some basic recommendations. There is a principle, if you will, that is quite famous, that you all might have read or hear about it, and it's the principle of the onion, right? The multi-layer approach. Creating a solution, whatever type of solution we have in mind, for example, an application, for example, a database, always following the principle of the defense in depth. The idea here, folks, is to add as many layers as we can to our solution. And it's not because just because we want or just because someone says so. No. The attackers, folks, whoever tries to attack, whoever tries to access our network, usually will look for a fast, easy way of penetrate and retrieve the data or get the benefit they want without a lot of investment or without a big effort, right? What we're trying to do, folks, by doing something like this, by increasing the layers of security, is reducing the time to collect for the attacker, and that way increasing the investment and the effort they have to go for to penetrate our defenses. This is a pretty common principle in cybersecurity, okay? Reducing the time to collect, increasing the time to collect and increasing the investment of the attackers, folks, usually will dissuade them from targeting us, or at least will make them think twice if we are the actual target they are looking for. I know this sounds quite weird because we're not talking about security, but that's one of the principles of networking. Designing with a multi-layer approach whenever it's possible. And that's the reason why we have this in our screen. there are a lot of scenarios where we might have, by default, one or two networks or one or two subnetworks, but in between the networks and stuff, we have so many stuff, so many things that are deployed that we don't even know or we are not aware of. For example, think about this. When we create a network in Azure, folks, let's say, but we're gonna do that in the next minutes. But when we deploy our first network in Azure, we usually get our network solution in a data center provided by Microsoft, right? So the first thing that you'll notice is that if you try to go to the data center, physically speaking, you are not allowed to go in. Even better, Microsoft has their data centers on undisclosed locations. When I say undisclosed, I mean that we don't exactly know the address. We know the state, we know the country, but we don't actually know the whole street and number. If by any chances you know where the data center is, it's not like you can just walk by and say, hey guys, I'm a big fan of your service. Can I have a tour? Or can you show me the facilities? No, they won't let you in. There are special data centers for that where you can actually ask for a guided tour. But in most cases, in most scenarios, you are not allowed to go in. So we have physical security. On the next layer, we have what we were seeing yesterday. Conditional access policies, authentication and authorization, identity protection, privilege access management, all the features of the Azure Active Directory to protect the authentication request. On this level, folks, we have the security for the users and the identities. If we keep moving deep, we start seeing network security. We have the perimeter and we have the internal network. For example, we have a firewall. For example, we have an application gateway. For example, we have a traffic manager or an advanced balancer with a firewall. Beyond that, we have the actual network, folks, the distributed denial of service protection, the internal balancing option. Then we have the computer. Inside of the computer, we have the security group. Inside of the computer, we have the authentication valid. Inside of the computer, we have all the things we saw for the connectivity, for example, of storage and data services. So we are now inside of the network. Up to this point, I have mentioned what? 6, 7, 8 different products. And I'm not even referring to half of the actual available services. So you can see what I'm referring to. What we want is to get all the way down to the data where we have the option of enabling platform protection, of enabling information protection. Okay? That's the actual intention of the designing of defense in depth, the multi-layer or the potato approach. Okay? So that's the first thing that we have, the idea of multiple options. Now, the network by itself, it's designed, even before we deploy it, with this type of idea in mind. The first thing that we need to know is, what would you like to have on your network, right? What is that you know that the network will do for you? Let me go here to the portal, so we can create a network and see the requirements of one. Let me just go here and get into my portal. There it goes. There it is. Okay. So the first thing, it's a network. There we are. So we're going to create a new network here. And as we saw on the slide, there are a few things that we need to include. First of all, well, the region, the subscription, all that usually is like granted, right? Like you know where, because that's the way of the subscription you're using for X type of product. So this is not a big deal. But the next thing, let's use this one, is the name and the region. Something important about the networks, folks. As long as you don't have them on the same resource group, the networks can have the same name, the same as the computers, okay? This is a pretty important consideration, because if you have a resource group or a subscription for testing and another one for production, you may have a VNet1 in both. Let's be clear about that, because sometimes it gets confusing for some users who are not behind the designing process. So for example, I can call this VNet 02, and I can put this on the East Coast. Remember that I have this blocked by my permissions, but let's continue here. Now, this is where it gets interesting. The networks, folks, in Microsoft 365, in CRM, in ERP, in Azure, in this case, for example, all the cloud services that we get offered by Microsoft are actually behind the principle of the network design. We don't see that because obviously, well, we have our front end, but Microsoft has the responsibility of providing an actual connectivity layer that is given to all their cloud customers with or without their explicit requirement. This means that whenever we create a subscription, like the one we're seeing on screen now, we get by default a network connectivity service. We don't see it, right? But the network is there. Why am I mentioning this? Because whenever we connect, whenever we get into our Azure subscription, for example, we get an IP, a temporary IP that is given to our session, or it's given to our service we're using, because we might be using a virtual machine, we might be using a storage account, etc. I am mentioning this because we the users, will usually get into a scenario where we might need, or we will need, the assignation of the IPs by ourselves. And this is when it gets interesting, folks. What type of IP addressing principle will you follow? Okay? What we have to do is the idea of using the specific segment that you might need for the distribution of the network. Okay? Commonly, take a look at my screen. You can see, if I select a /16, I will have 65,000 IPs available. That might be a lot, that might be not enough. It depends a lot on what each of the users or what each of the requirements states. But in reality, or in a real scenario, we might not be using half of them at all. This is an important part because I've seen, and maybe some of you might have faced this, or maybe some of you might have done this, but there are a lot of cases where we get hundreds or thousands of available IPs just in case. This is not wrong, but this is a designing class. This is not a management class, okay? And from a design perspective, it is not correct that you assign or you reserve thousands of IPs that you know you won't be using. I've mentioned this hundreds of times to my attendees, to my students, to my customers, because it's pretty common that you go and you say, hey, I have 100 computers, use a /16. You're going to have 65,000 available IPs for 100 computers. It's not going to have an extra cost for you. It's not going to have an overhead management or an exceeded management for you. It's not like you're going to actually have to pay for each of those extra IPs. No. But from a proper design approach, folks, using this type of segmentation might be redundant or might even block and overlap with some other requirements that your same organization might have in mind. A best practice, folks, and this is important you get a note because this will be on the exam, is that you keep in mind that the networks that you will be using or the IPs that you will be using should be enough to support your business as usual and any extra gap that you may have up or down. Again, there is no correct answer because we're talking about networking. But look at this. If I go here and instead of using 16, I go for a /20, I have 4,096 IPs. That might be enough. Okay? Yes, we can. I'll go to that point in a second, Dylan. So we have here a 4,000 IPs available with /20. Important. We cannot create a network without a subnet, but after created, we can delete the subnet and leave the network empty. That's a weird thing, I know, but it's how it is. So as you can see at the bottom of my screen, I have an actual message, an error message saying, hey, I need a subnet. Once I create the subnet, I'll be asked to continue the deployment, and then I can delete it if I want. Check this out. I can go here to subnet 1, 10.1.0.0 slash, say 24. There. A couple of important things before I continue. First of all, the network in Azure, we don't have a DHCP, okay? The DHCP, the way we know it on premises, does not exist in here. We have a service called the Azure IP addressing service that will be the one responsible of looking for the available segments and the available IPs and assigning them to the objects that requires them, okay? You can see it's given by default 10.1. The reason is that if I go to my networks here, the 10.0.0.0 is already used by a network we created on Monday when we were checking the policies, remember? So if I go here and I use this one, the VNet 1, you can see this is using the 00. So my service, not my DHCP, my IP addressing service is actually giving me the next one. But check this out. I can do this and there is no error. There is a warning. Hey, you have another network using that specific address space. As long as you don't connect these two networks together, you're good to go. This is a pretty important part, folks. When we're designing, we have to remember that Azure will let you overlap the segments even on the same region and the same resource group without an error. If you want to connect them together, if you want to do something beyond that, well, that's when the magic happens and you are not allowed to. But I can actually create it like this. So I'm gonna do this and you'll see the whole process of redesigning in a minute, okay? This is not correct. This is actually a bad practice because I'm overlapping. What I want you to see is that we have them together. We have security services. We're going to talk about the security services in a minute. That's the final part of this first module. But it's important we know that by default, or at least something that I consider pretty relevant, by default, every product, every object you connect to the network is automatically protected by distribute denial of service protection, the default one, okay? There is an advanced distribute denial of service protection that uses prioritization and investigation tables. But by default, folks, and remember this for the exam, every single thing that you connect to this network will automatically have distribute denial of service enabled, okay? This means that if multiple requests land into my network trying to access one of my objects, it will automatically determine if it's a threat or is a regular type of petition. If it looks to be a threat, if it seems like a threat, it will automatically block it, okay? And the petitions will be dropped before anything wrong happens. That's the idea of distribute denial of service, obviously. And in this case, well, what we're trying to do is to protect by default every single object that we might connect in here. We can connect a firewall. We'll talk about that in a minute. And we have the option of enabling something called the Azure Bastion that works as an intermediate appliance or an intermediate computer between my internet-facing sites and my backend computers. So the idea is that my computer 1, my computer 2, my server are not exposed to the internet. Instead, we have an intermediate appliance. That's the Bastion host. Okay? We have the tags. We'll review. There it goes. And I'm mentioning something. I think it's my location. As assumed here, I can only create on the EaseUS. There we go. And we create. We have our network ready. So as you saw, well, think about what will you have on that network before you deploy. I think, and this is a personal opinion, but I think the most important part of this pre-planification, it's the actual segmentation, folks. As you saw, the segmentation might be tricky because if we don't analyze the networks we have, the available IPs we have, we can actually, or we might actually get in the middle by overlapping segments without noticing. Okay? So this is the first thing. Let's continue here. Now, once we have a network pulse, remember that we have the chance of connecting to an on-premises solution. This is a pretty common approach. I will dare to say that 70 to 80% of the network users in the world, referring to Azure network users, somehow will have a connection to an on-premises network. There are a lot of options to do this, okay? We can have direct endpoints, we can have direct connectivity, we can have remote connectivity, but what we need to know is that the most common approach that we can have is the usage of a VPN. We can create a virtual public network by deploying a gateway, a virtual gateway in Azure that will connect and trust an on-premises gateway that we will have existing, and that's the actual word, physically on our physical location. Your company might have, for example, a branch and a head office. On each of them, you have a gateway that lets your users to consume internet services, right? That's a common scenario. That's actually something quite standard. If you want those two networks, branch and head office, to connect to Azure directly without using a public connectivity, using the internet but on a private defined connection, you can create a VPN gateway for both. The VPN gateway, folks, can use a border gateway protocol, and you can actually have all your products from point A to point B, from point B to point C, available and visible to each other. A gateway, folks, a gateway in Azure refers to the principle of we the users, actually having something that will let my computers or my services on premises to be compatible, to be available, and to be allowed to see and interact with my computers and my services in Azure. This gateway, folks, that we can create requires, physically speaking, a device on premises and requires a gateway in cloud. Important, and I think this is useful. If you are a user of a third-party cloud product, let's say AWS, let's say GCP, you can use this gateway to connect to them, to connect with them. Okay? So, an important part of this connection, the gateway will actually enable the traffic to come in and go out to the Azure services, regardless of what you have on the other endpoint. Okay? So, for example, I might have an Azure subscription, I might have an AWS subscription, a GCP subscription. I need one gateway, and I can create two connections, one for GCP, one for AWS. Okay, remember, the traffic will go out via the internet to get to those points. That's an important or relevant piece of information. So we can create a gateway, go for a VPN, use the internet connection, and get the connection. Now, there is another option that is quite actually important called the express route. This is the fastest and most reliable option for intersite connectivity, in Azure. But obviously it comes with a few challenges and a few considerations. First of all, express route, folks, is not cheap. Okay, let's be clear. I'm not saying it's expensive, it's costly. It's not the same. The express route, my friends, refers to an option that we have where we connect from our office, from our location, to our internet service provider edge point directly via fiber channel. They, let's say AT&T, for example, AT&T has a direct connectivity using fiber channel to a Microsoft data center. And from that data center, we jump all the way up to Azure. So we never go to public networks. We never go to an internet connection. We use private circuits. Location to service provider to Microsoft routers, Microsoft endpoints, Microsoft directly to cloud, to Azure. The thing with ExpressRoute is that it could get expensive. We got a message here from Richard saying the VPN gateway is not cheap. I'm using Basic and Microsoft have decided to retire it. Yes, the Basic one is actually legacy now. Well, these products are expensive. The VPN, the ExpressRoute are expensive products or costly products. It's important we consider that based on the traffic, based on the amount of information we share, based on the content we have in between, we will actually get a pretty substantial, if you will, amount of money on our invoices. And that's normal. And that's because the way the product works. We have a charge, we have a bill based on the information we share, the transactions, the amount of time we keep the connection open. So in some cases, folks, ExpressRoute might actually get cheaper. Consider this. By default, ExpressRoute can get up to 100 gigabits per second. That's, I think, enough speed for a migration, for a production dependency. We have dynamic scaling. This means that instead of having 100 gigabits all the time, we can go to a pretty small thing like 2-3 gigabits per second that will increase and decrease based on the demand. In these cases, you reduce a lot of the cost. You don't have a complete open bandwidth the whole time. You use it based on your needs. You can connect on an inter-site solution. This is an important one. For example, I have a customer, an oil company in the US, who uses ExpressRoute on their Texas office and their UK office in London. They have 2 circuits. All the other regions they have will connect internally using MPLSs from their location to their data center, for example, from Canada to Texas, from Mexico to Texas, and then they'll use the ExpressRoute circuit. It's faster and cheaper than using a VPN from Mexico to cloud or from Canada to cloud, for example. That's an option we have with ExpressRoute. Okay? The best of all is that we can have them both together. We can have an ExpressRoute and a gateway for a failover. In case of an issue, we have the gateway ready to be used, right? We have the gateway, the VPN is ready, we use the internet connection, the ExpressRoute might be failing, but we still have the connectivity without compromising our products. That's the idea of the failover, folks. Okay? We can configure both. Obviously, we will have 2 different VPN gateways. Well, one VPN gateway, one ExpressRoute gateway, with the cost that comes with both. Okay? If we put all of these services together, if we create an interconnectivity between objects with all these different services, folks, we get to a virtual wide area network. We can have multiple regions in Azure. We can have multiple countries, physically speaking, covered by our branches. We can connect a few of them via ExpressRoute, a few others via VPN, and all of them with each other. So we create a wide area network. This becomes the idea of a global transit network that we can use to go from point A to point B, regardless of the physical or geographic location. These are really useful options, folks, because we don't have to have a connection of one-to-one on every branch, on every service, on every product. As I was mentioning, we can have a few regions connected together and a few others connected on the backend. And again, maybe some offices will have direct connection to Azure, and some others will have connection to those offices with connection to Azure. So what we do is we put them all together and we let them talk to each other. Okay? This is a really common practice. Okay? It is important, folks. It is important that we have in mind that this connectivity, as Richard was mentioning, might be expensive. It might not be the cheapest option in the market, but again, it will represent a full connectivity or a full available connectivity for every object in and out of Azure. Okay? So that's one of the options that we have. And that brings me to another connectivity topic, but yes, Max. Max is asking if wide area network will be a combination of things, gateways for express route and gateways for VPN. You can do it just with VPNs, or you can do it just with express routes. The idea of the map is that we can have um, different geographic locations, all of them interconnected in between and connected to Azure, to the cloud, maybe via one or two objects. Okay, so that's usually the understanding, Max, of using a wide area network with Azure. Okay, so the answer will be yes. We can use one and or the other or both. The VPN gateway, okay, and the express route gateway. Okay, now we have an intersite connectivity between networks. We have a question on the chat that says, "Is Azure Virtual Wide Area Network?" I'm assuming that's transitive instead of transitive, Eder. But the sorry, Nilanjan, but the answer is yes. We can enable transitive services or transitive traffic in between the networks. I'm going to show you that in a second. Okay, so that's it. Eder is asking if we have this available in all the countries. The answer is yes. There might be some limitations based on the country. Some circuits, some endpoints might not be actually available, or the whole speed might not be available. This depends a lot, Eder, on the providers you have. Okay, it because the express route circuit it's provided to you by an internet service provider. So it depends on what you have in your country and the capacities or the speeds they can offer. The virtual network gateway, the VPN, and the wide area network is actually available everywhere. Okay, so we have referred to the connectivity sorry for on-premises to cloud. But what about connecting two networks together, right? We have completed the left part of this diagram. We have an office, a branch connected to the Azure gateway. But what if I have two networks that I want to make talk to each other, to communicate with each other? In this specific scenario, folks, the planification we had for the IPs, remember, the segments, becomes relevant because we need to be sure that the IPs are not overlapping and that my services are not actually using the same IPs if I want them to talk to each other. If you remember, based on my demo, I have two networks now with the same segment. They can coexist. Both of them can exist at the same time. But the moment I try to connect them together, that will fail. How do we connect two networks together in Azure, folks? There are two options. We can use peering or we can use a VPN. And you might be thinking, why would I use a VPN if I can connect to networks using the backbone of Microsoft, the peering? This is important, and it's for design. If you peer two networks together, like the right part of this diagram, the hub, the spoke 1 and the spoke 2, if I peer them together, folks, I'll use a dedicated list of circuits provided by Microsoft that we don't actually see, we don't actually compare, and will give us the fastest and the most reliable security. Yes, but guess what? You don't actually see how your computer 1 gets to your computer 2, talking about all the jumps on or intermediate spots. You just know your computer 1 can see your computer 2. For compliance, or for some regulatory principles, this is not correct, right? I remember in the bank, before I left in 2016, we had a requirement for, well, from the government to prove or to provide evidence on how the customers were getting from different countries to the main data center we had with all their information. And they wanted to see, the government wanted to see, all the different spots that were used as jumps between the household and the data center. Trust me, this is more complicated than it sounds. If you use a peering between two networks of Azure, you cannot get this information. If you have the need of showing that evidence of all the involved spots, you need to connect network 1 to network 2 via VPN. It doesn't matter, both are in Azure. That's an important consideration, okay? The actual connectivity, folks, you can see here, might be one network to one network, multiple networks to one network, multiple networks to one, multiple networks to other, and then both of them together. Take a look on the third diagram. We have all the networks on one region, all the networks in another region, and just two networks, one on each side, connected to each other. And it depends a lot on what would you like to do. How would you like your services to connect? Okay, let me show you here. I'm going to show you the peering. So here it is. We have our network, right? Here. There. So both of our networks of this class have the same segment, 000. Right now, I have no issues. But the moment I try to connect them both, I can go here to peering, and I can click on that. If I try to connect VNet 1 to VNet 2, check this out. I can select here my VNet. You can see now the space is actually giving me an issue. This is pretty important. I already mentioned this, but it's important you remember it, folks. So I'll repeat. The network can coexist with the same segment, but the moment you need to use them together, the overlapping will be an issue. Okay. One of the benefits of Azure that has, it's actually quite a good thing, is that we can modify the segments. Okay, we can modify, add, extend, or reduce even after deployment. That's something you cannot do in AWS, and it's limited on GCP. Check this out. If I go to my network 2, here, I can extend or reduce the space here and save it, or I can remove this space and create a new one. To do that, if I try to delete this, check this out. If I try to delete, it's gonna fail, and the reason is that I have a subnet under this segment. You can see it's not allowed, right? I can add my new space there. I can try to delete and save. You can see it fails because the subnet is there. So what I have to do is, first of all, delete the subnet, this one, there it is. Step 1, get rid of the subnet. Step 2, add a new address space. Step 3, delete the old address space. So I can go here, 10.1.0.0/20. I can save this, or I can remove now this one and save it. There it is. You saw? The network never changed. The actual service itself, the name and the location and stuff, didn't change. What it changed was the actual segmentation. So I can go back, I can retry, and you can see there is no error. Well, I should wait and I should do it again. Let's do it here again. So let's call this VNet 1 to VNet 2. we got a question about being transitive. Okay, we can have here traffic from this network 1 to the network 2 allowed. Traffic from network 2 to network 1 allowed or denied, allowed. I can have a routing server in the middle. That means that any traffic that comes via that network will be redirected, the transitive network, allowed. From there to here, I'm going to call that VNet 2 to VNet 1. I'm going to have here my VNet, allowed, allowed, and add. 5 minutes later, we have a connection between my networks. Both of my networks are now connected, folks. It is important that whenever we do something like this, whenever we go for something like this, folks, we include in our plans all the possible variables of IP addressing traffic management. If I go to the network 2, check this out, and I go to peerings, you can see it's now connected. If I put a gateway on VNet 1, I can use a transitive service to come head office to network 1 via VPN, network 1 to network 2 via peering. That means head office to network 2 via VPN transit peering. You see? And now it looks like a big, actual wide area network. That's what we're trying to achieve in here. Okay? So this is the option that we have to connect to networks using the Microsoft backbone. Remember, I could put a VPN on both, well, a gateway on both, and create a VPN in between. It's not a bad practice, okay? Do not consider that a blasphemy. It's actually useful. And again, it might be needed. So we can do this if we want with all our networks. We can connect all the networks together. We can have one single network and then all the networks on the backend. One network facing the internet and all the others on the backend layer. You see? That's the idea, my friends, of using the peering. And finally, for this specific topic, we can also design based on routing. By default, when we try to access a computer, when we try to access a database or something, we get an automatic routing provided by Microsoft, okay? There are scenarios where you might want to add your own routing to create an intermediate computer, to add an intermediate endpoint, for example, to catch the traffic, to register the logs, to monitor the entries and exits, etc. As I said, by default, we have a system route. The connection goes the fastest way available from internet to endpoint, endpoint to backend, and that's it. But we can add, if we want, a user-defined route. Question for the exam, is it true or is it possible to use this to redirect the traffic via 2-3 different intermediate appliances before getting to the final destination, to the backend service? The answer is yes. Take a look on the bottom diagram. You can see we have two different yellow boxes that in this case could be appliances. So I have two more jumps before getting to the database or before getting to the computer where the actual object is located. And we're doing this for security purposes, for login purposes, for traffic control, for management, etc. This is the idea of routing. Okay? So we have these options available for every single time we create a network. So we have created a network, we have configured our network, right? We modify a couple of things, we connected both together, we have a peering, we have both available to each other. Now it's time to continue here using some of the features. Any questions you have, folks, please let us know in the chat. Are you charged for VNet to VNet? No, Richard. Well, it depends. The easy answer is no. But it depends on a couple of variables. For example, if you have two regions in complete different geographic locations, there might be a charge for reading. But it depends on the region. Some exceptions that will have a cost. Germany East, because that one is handled by T-Systems. China North and China South, both are handled by 21 ViaNet, that it's a service provider. the government networks of the United States. In those specific cases, there might be a small fee, let's say 2 cents of a dollar for 10,000 reading transactions, like a pretty small amount. But just in those specific cases, the correct answer or the actual answer will be no for any standard connectivity. Okay, but in some cases, let's consider that there might be a pretty small amount of a transaction cost, if you will. Okay. So any other questions you have, folks, about what we have done, the connectivity, the hybridization, etc., please let me know. We can configure, we can discuss anything else you want. We're going to continue here before we go for our small break, and we're going to talk about the delivering of services. This is a pretty important one because we have a question. Do you have a standard like SOP on how to assign unique IP addresses to space without overlaps when you create? We can define our own standard address. We can create a policy to avoid overlapping on resource groups and subscriptions with a policy. There is an option to add a policy to avoid any type of overlapping, or we can follow the recommendation of the service provider. Because as you saw, every time I create a network, and check this out here, every time you create a network, you're actually given by default with a suggestion of the next available IP, right? So for example, if I do this, you can see it's automatically giving me the next available IP. And the same happens with internal IP assignation. If I create a computer and I put it on this network, it will automatically get the first available one. The next computer will get the second available one, and we'll always follow that. It's like a lightweight DHCP, but again, it's not actually blocking anything. I can overlap the IPs as you saw, right? So if you want this recommendation to always be followed, to have multiple infrastructure solutions, a policy will be the answer. Okay? So that's just an FYI. So I was saying, folks, okay, we can get to the network. Good. We can achieve the connectivity without issues now. We are capable of getting from point A to point B by using the peering or using the VPNs. We're good. The next thing we have to consider or we have to worry about, it's the actual usage of traffic inside of it. Okay? The first product we have is a load balancer. We all have seen, or at least we all have referred to a load balancing solution at some point, right? The load balancing, as you know, refers to the principle or to the option of receiving traffic and taking a decision about the best option available to attend that request, right? Based on the petition I'm getting, what will be the best destination to land the request? That's the idea of a load balancer. Now, when we have a load balancer, folks, we usually get into a scenario of how would you decide what is the best option? That's the catch of this, or the tricky part of it. We have a balancer available in Azure called the Azure Load Balancer that we can use to take these decisions. We have different type of balancing solutions in Azure. Let's mention that before I continue. The basic one, let's say, it's an option that we all get to configure internally or externally, remember this, one or the other, a traffic catcher that will analyze the backend and based on the time of response, will allocate the traffic. Important, the balancer, folks, uses a round robin. Okay, this is pretty important. The balancer cannot be redirected based on affinity, cannot be redirected based on variables of the petition. We have another application for that. The balancer itself, folks, is, okay, I have 5 computers, right? I get a connection. All the traffic that it's coming in will go to those 3 computers we have on the backend. I will go to the first computer and will knock the door. I can wait, I have to wait at least 5 seconds. If after 5 seconds I don't get an answer, I go to the next computer on the list. I knock, 5 seconds, next computer, and so on. That's how it works. Okay, so it's pretty important. I don't actually get the question, Max. Like the load balancer, what does the LB use? It uses round robin, and it uses something called the hail proof to reach the backend computers. I don't know if that's what you were asking. If you can elaborate a little. So the balancer can be internal or external, with a public IP facing the internet or with a private IP on the backend of the subnet. You cannot have a balancer in both layers. Question for the exam. You have to create one by one. Okay? You want it or not. Okay, I was correct. Thank you, Max. So, important folks. The balancer can have a routing based on the port and the protocol, like all the UDP traffic to balancer A, all the TCP traffic to balancer B. That's it. As I said, there is no affinity configuration. Okay? It's important. The balancer can be free or the balancer can be paid. The free one, as the name suggests, has no cost, but it has some limitations. First of all, you can only have up to 300 computers on the backend. This means that if you have 301 computers to be used by the balancer, the free one won't work. And the reason is that you have to pay, obviously, for more than 300. First thing. Second consideration of the balancer, folks. The balancer cannot be used, the free one, with a security group or a semi-configuration of a firewall. If you use the paid version of the balancer, you get by default the assignation or the requirement of a firewall existing before the balancer is configured. Talking about a firewall, we're talking about a dedicated security group on the computer. That's okay. But the balancer, the free one, won't require that to redirect the transaction. The paid one will, okay? Option 2. And, sorry, option 3. The paid one can actually be migrated or used as a baseline to configure the next service. So that's the consideration. Again, let's summarize here. Internal or external, okay? No affinity, round robin, and that's all. We have the option of using a balancer on steroids. And that balancer on steroids is called the application gateway. The application gateway, my friends, will let you, the user, to have internal and external balancing simultaneously. The application gateway will let you folks have a web application firewall or an OWASP, you might have seen that, with a list of rules of common traffic threats identified for applications and traffic control. And that exists internally. The application firewall that we have on the application gateway can be for monitoring or for action taking. You can analyze the traffic before it goes into your network, or you can let the gateway take the whole decision and then block the petition before it's delivered. This is an important part for the exam when designing. Why? Because the application gateway, folks, will be able to give you the insights of what has been attempted to be attacked or what is behind the attack attempt without letting the attack to happen, or you can kill the attack the moment you identify it. You may be thinking, hey, why should I let the attack to go further up to a decision making without or like considering that could be a threat, right? In some cases, you might want to see what is being attacked, why it's being attacked. So you might let the gateway to route the decision, and before it drops the connection into the destination, it kills it. So that's an important part of this one. The web application firewall can be on the front end of the decision or the back end of the decision. We can use Secure Socket Layer or TLS and determine the traffic. And we do have affinity in here. Based on the variables of the petition, port, protocol, IP, destination, type and size of packets, we can decide which backend pool will be used. On control of the balancer, where we have a straightforward decision, this one can actually work further. That's the idea of the gateway. Okay, so no, Chandras is asking if the DDoS protection is based on an application gateway. It's similar to an application gateway, but it's based on sensors, on incoming traffic sensors. Okay, so based on the amount of requests that the sensors start receiving, the DDoS is triggered, enabled, or disabled. Okay, so that's the idea. We have an important question here from Max. Let me read it. In the diagram, is the application gateway subnet paired with other subnet? We have here the VNet. You can see we have the subnet of the application gateway. It should be paired, actually. And the diagram is not actually showing the pair, but it should be, because if we had the application in here, for example, and we want to get there, we will need a peer in here. Important. That is if we want all the traffic to correlate, because the application gateway can connect directly to the object without appearing. This is an important one. If we determine that the application service, the one we have there on the top, behind the X, it's the destination of the backend pool, we can connect it directly to the gateway without the two networks being paired. Or since we have them, for example, in this case, all of them on the same subnet, a peer is not needed. Okay? Remember, as long as the subnets, because we have subnet 1, subnet 2, subnet 3, subnet 4, as long as all the subnets are on the same VNet, the peering is not needed. If these were two different networks, we will have to peer, or we will have to do a direct connection. Okay, so that's a relevant one. So Eder is mentioning that they use web application firewall, and it's a little bit expensive. It is not cheap. Actually, both firewalls, the web application firewall and the whole management firewall, are expensive. A full functional firewall, I'm getting ahead of the content because that's the last lesson of this module, but a full functional firewall, folks, might cost up to $6,000-7,000 a month. And that's not cheap, actually, but well, it's how it is, right? So, okay, the last topic we have here, and we're gonna go for a break before we continue, is the content delivery network. I think you might have used this, or you might know about it, but let me explain how it works so you know the idea. You have, let's say, origin server. Let's say that we have a streaming service in here. Let's go here for Netflix. We have Netflix in here. This host is on the UK. Okay? There is a new movie coming out today. 1 a.m. in the morning UK time, the new movie will be out. You are in France or you're in Spain. You want to watch the movie. From France or from Spain, you request from your TV, from your device, you click play on the movie. The movie, folks, will actually be dropped into a content delivery network. This is a cache location in France or Spain. You'll be buffering and loading. We're not there yet. We're still getting there, Nilan. So we get the movie, the file, into Spain or into France, and we watch it from there. The administrators of the data center in the UK will have determined by now how long they will keep that cache in France and Spain based on their consumption. And whoever comes after you to watch the same movie will read it or will watch it directly from the delivery cache, not from the source material. That is a content delivery network. The idea is that we can optimize the time of response and we can reduce the latency of our users. And obviously, make it faster for everyone, for the users and the owners. In Azure, folks, we can use Azure Content Delivery Networks and we can use Akamai delivery networks. We can also use, I think there are some Verizon delivery networks somewhere in some regions of Europe, but we can wrap by saying it's Microsoft and it's Akamai. The delivery network, folks, can be configured to retain the information for seconds, minutes, hours, days, weeks, months, and years. Obviously, it has a price for the size and the amount of time, but in a real scenario, in an actual optimal scenario, when we go for this type of content delivery network, folks, we reduce the time of transaction, we reduce the time of response, and that obviously improves our cost. Okay? So we're going to stop right now. We still have a couple of topics about traffic management. We have the front door service coming next, but we're going to stop for our small morning break, and we will be back to discuss the front door, to discuss the traffic manager, and then we will go to the application protection to wrap up our theory of the module one. We will go to the second lesson. The second module is pretty short. It's the disaster recovery, and we will be done for the day. So let me get here the timer, folks. Where is my timer? Here. I'm gonna go, we're gonna have 10 minutes. We have enough time. We'll be back and we will continue with our second half of our morning. Thank you very much, folks. We're back, team. We're back. We're going to continue here to wrap up our module because we are not done yet, and we will move forward to the next part. So, what else we have? We're still talking about some of the objects and products we can use to help our application be distributed via network, right? The next thing that we have is the front door. What is the front door, folks? The front door will create a global floating DNS. That's the easiest way of understanding. Okay, let me explain it. You have an application, okay? The application, let's call this Arturo's app. ArturosApp.com. That's the DNS we're using to solve the application and get to it. The application is hosted in the United States. If I create a front door, folks, and I put the front door with the ArturosApp.com, every single edge point, edge location in the world will be able to solve it and send it back to the Azure location. What's the difference? If you go into ArturosApp.com without a front door, you will solve that via global DNS, and then you will be redirected via the internet from your location, let's say Japan, all the way to the United States. Internet, 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 until you get to the United States data center. If I use front door, I have Japan West as a region, and I have an edge point in Kyoto. So the resolution will take place in Kyoto. It will travel to Japan East, and all the traffic will be redirected back to the United States using the dedicated Microsoft backbone, a private, faster, and safer than an actual internet connection. That is a front door. You have that actual configuration available in every single location in the world. And your users, or whoever is trying to solve, will have a faster experience, a reliable experience, let's say safer experience, if you will, because that's a reality. And for you, you'll know that your traffic is coming from an actual internet location, just from the connection of the user to the front door. Everything else was done via the backend of Microsoft. This is a front door. Okay, I thought an Azure front door. No, Ahmadu. That's a usual confusion. The content delivery network is a storage location, an actual cache location. You can put a front door to solve into a cache location, but the front door is just a DNS. It's not a DNS only. I mean, it's a service, but it's easier to understand like a floating DNS that will let you solve to the content delivery network. You can put a front door, okay, and then a content delivery network on the back end if you want. But a CDN is an actual service to catch, and the front door is a service to solve. These are two complete different things. They can work together, yes, but they are not the same. Okay, so just for the confusion. So this is the front door, folks. We can have multiple front doors for multiple resolutions, multiple names, and all of them will be catching and sending to the backend the way every other service does. Okay? Any questions so far? Let me know. This is our next service. And finally, to wrap up the application, we have something called the Traffic Manager. The Traffic Manager, folks, it's a solution that we can use the same for a DNS decision, but fix it to a region. The front door, remember, is on the edge locations floating around the world. The Traffic Manager exists in one region. Correct, Milan. It's a floating DNS service, floating, global, if you will, okay? Because the Traffic Manager also uses DNSs. The difference between a Traffic Manager and a front door is that the Traffic Manager, folks, exists in one region. Okay, you have to select a region to create a Traffic Manager. The Traffic Manager will receive the request, and based on the variables of the request, will determine where to send it. It's not a balancer, okay? It could work similar to a balancer, but it's not actually balancing the loads because it's not checking for the capacity of the backend services. No. You receive, for example, a transaction. Let's say that you have this on the UK. You receive a transaction from France. The traffic manager is capable of seeing where your transaction is coming from and sending you to the closest location to France, maybe even France data center. Your connection will be redirected and you'll be landing on France, for example. Second option, you can use the traffic manager to select based on the weight. You have 3 computers. 2 of those computers are actually for production, 1 is just in case. Computer 1 and computer 2 are heavier than computer 3. We determine the weight manually. Let's say 10, 10, and 5. As long as we have one of the 2 10 computers running, the traffic manager will go to that. If 10, 10 are done, it will go to 5. Or if we have 10, 8, and 5, we'll always go for 10. If 10 is degraded, we'll go for 8. If 8 is degraded, we'll go for 5. The traffic manager is just to allocate the petition. But again, it won't actually won't evaluate the state of the computer, like the capacity, the overloading, etc. That's not something that it does. It's important we get that. Okay, so these are the different options we have for the traffic manager. We can put a balancer behind the traffic manager, and we can put a fronter in front of the traffic manager. So we connect from Japan, the fronter sends me to the traffic manager in the UK, the traffic manager sends me to a backend balancer, a public IP, and the balancer determines the best computer for my transaction. We can put together all the services we have seen in here. That's the idea, my friends, of using different type of traffic controllers. Any questions, folks? Anything here that you would like to discuss, please let me know. These are the options for traffic control, for applications. The final part we have here, before we wrap the lecture of networks, remember, folks, that this is a specific type of session that goes through the content in a 2 hours period. In a real class scenario, I'm just mentioning this because it's important you know that this module will have taken 2-3 hours because I will be showing you everything, how to configure every single piece, and at the end we will have a complete solution with a fronter, with a traffic manager, with a balancer. Nevertheless, remember that tomorrow I'll be sharing an extra link that it's mine, where you will be able to find a few extra tips and include some videos of this type of stuff. Okay? It is, Richard. It is. Let me see if Joyce can find the table, the comparison table of traffic control for you. Okay? So that's I'll think she'll be helping you with those 2 questions you have on the chat because she has access to the documentation. So the final part here, folks, before we go for the disaster recovery and business continuity, it's the service endpoint. Okay, our service endpoint, folks, well, our security, it's based on different type of things that we can put together for our services to work. Yesterday, you saw me creating a service endpoint, remember? Remember when we were going yesterday? No, on Tuesday. You saw me creating a storage account and using a service endpoint to block the storage account, remember? The service endpoint requires that the traffic comes from a pretty specific IP to let the access be granted. You remember that. I created a storage account. I was the owner. I created a container for blobs. I created a file share. And then I block a service endpoint behind the network. And when I tried to access, I was blocked because I was using a public IP, remember? That is a service endpoint. Now, there is an option. This is a public service endpoint, remember? There is an option to go even further with an Azure private endpoint or a private link. The private link is similar to the same we did on Tuesday. It's about you only filtering. Think about this like a funnel, putting a funnel in the middle where the access can only be granted by a specific public IPs and a specific private softnets. You want to get to the storage account, you need to use a VPN or you need to use an express route. Now that you saw that, now that we know what is that, to get into the computer, and from the computer, jump to the backend of the storage account. The difference is that this one can be used between two services in between without actually going for an external connectivity request. And this one requires that the external connectivity request comes from a private or a hybrid connection. In this case, you can see on the diagram, we have an application, sorry, a network gateway. You see? That's the idea of a private link. So this is one of the security features we have. The next one we have, and this is one of my favorites, are the security groups. Let me turn on this so I can show you. A security group, think about the security group, folks, the network security group, as a lightweight firewall that you can have on the network interface card or on the subnet. That's it. It's an access control list that will filter incoming and outgoing traffic of your virtual machine or your soft network. That's it. These won't be used to face the internet. This won't be to face external traffic. I mean, on a network. This cannot be used on a database. This cannot be used on a, I don't know, on a storage account. This is only compatible with soft networks and with network interface cards. When you create a computer, you always create a security group for the interface card. You want it or not, okay? And then it follows the principle of a firewall, inbound and outbound rules. Let's see. If we go here to networking, you can see I have different options. I have added this on my own. I'm denying all the traffic of SQL to come in. You can create rules here. Any source to this destination, this is the computer. What service do I want to block? It's a stateless, Milan. Actually, I want to mention that. It's a stateless. Okay, you have to manually replicate the rules when you need them. So I can go and say, I want to block Cassandra. Do I have Cassandra here? I can look for it. If I don't have it, I can add manually. You can see here I have Cassandra here. That's the port. I'm going to block Cassandra. Here, deny Cassandra inbound. And take a note for the exam. The highest priority is 100. Okay? From 100, the higher the number, the lower the priority. So if I have 100 denying all traffic and 101 allowing all traffic, it will be denied. Best practice, folks, leave at least 10 spaces in between, or 5. You can say I have 105 and 110. The idea is that if you have an emergency, you have enough spaces to put an overriding rule. Okay, so I'm gonna go here, say 115, and I have my rule. This is a stateless. I have my firewall, well, my service ready here. I can go to outbound, and you can see there is nothing. That's why I was mentioning it's a stateless. You won't have an immediate replication. Okay. Now we have the option of the layer 7, where we get the firewall. Okay, this is, remember, on the layer 4 or my computer or my subnet. On the layer 7, we can have a firewall. The firewall is the firewall as we know it, right? The old big chunky firewall that we all have used. Today, folks, and this goes to Nilange's question. Nilange is asking if there is any stateful firewall in Azure. We have the firewall as a service, the modern firewall as a service that we can actually transform into stateful by using the firewall manager. Okay, the firewall follows the same principle that we saw on my security group. We have inbound and outbound rules. We have 100 to 65,000. We have allow or denied, and that's it. The same exact thing. The difference, folks, is that we can go to the cloud Defender, the green shield, select the firewall manager here, and transform all my firewalls into firewall as a service. In here, I can create rules to make it stateful. I hope this answers the question, Elijah. You can create a firewall that you'll configure one by one. If you have 5 firewalls, you have to configure one and each of them independently, inbound and outbound independently. Or you can put them all together in a modern firewall manager, is this one, and replicate from here any rules and create stateful policies for all of them. As I said before, we got that comment also from one of our attendees today, the firewalls are expensive. This one and the web application firewall are not that cheap. But again, it's pretty important that we remember that a firewall might be needed. We have the firewall alone, we have the Azure firewall with a gateway, we have the Azure firewall, the gateway, and the application firewall, for example. We can have multiple layers of security. Remember the first slide, right? Designed based on the principle of defense in depth. Okay? So we can create a firewall, centralize it in here, or we can manage each firewall independently from the others. And then we actually saw a question of this on the chat earlier today. I was going to answer it right now. The DDoS protection. As I was mentioning, the DDoS protection is not an application gateway. It uses sensors. It uses sensors to actually catch the repetitive petitions and determine that you may be under attack. By default, the free one is enabled. We got a question and someone said, it's disabled on your network. No, what is disabled is the standard one. You can see here, standard. By default, I have my free DDoS enabled. I don't even see it here because it's already enabled. What's the difference? The standard one will let you prioritize the resources, will let you learn from the traffic, give your feedback to label or mark false positives and false negatives. The standard one will have also real-time alerting and will have analytic response. That means that you'll have a complete report. On the free one, it only protects you. And it works okay. I'm not saying that it's bad, but both of them together are usually seen as an option. So again, the moment you create a network, you have DDoS protection enabled by default. Every single service you put on that network will be behind the DDoS free protection. Anytime that there are multiple sensors receiving the same petition for the same target, it will trigger the free protection, will analyze the traffic, and if it looks like suspicious or abnormal, will automatically kill the petitions. That's it. The advanced one or the standard one will give you all these extra things, that it's real-time monitoring, real-time response, real-time alerting, adaptive turning, that it's basically machine learning where you can pitch or send feedback so it learns from the detections. But this is there. This is something we all have. Okay? We also have, as you saw, the Bastion. I already mentioned this earlier today, but the Bastion, folks, will let your users get to the computers via an intermediate host. Instead of opening remote desktop sessions and HTTPS in your virtual machine, you block the HTTPS, you have it on a private subnet, and you connect to the subnet via the Azure Bastion. The Bastion opens a login page, you authenticate, and you get to the backend computer. The session is over, you stop Bastion or you close Bastion, and on the backend, the computer remains intact. So the Bastion is also a little bit expensive. I mean, all the security services are costly, but you can have multiple computers in the subnet, not one-to-one. One Bastion per multiple computers to be connected. So that's a good thing. If you don't want to create, remember the user-defined routing, the UDR we saw earlier? If you don't want, yes, Richard is mentioning the same I'm saying. Azure Bastion is a nice feature, but again, it's expensive, yes. If you don't want to use Bastion, folks, you can put an intermediate appliance virtual machine to catch the traffic, and then redirect it. Bastion, this is a personal recommendation, okay? Bastion is a nice to have, and it's recommended or actually suggested to be used when you have multiple computers to leverage the Bastion. Having one Bastion service for one computer, I personally think that is too expensive. I think that it doesn't worth the price for one single computer. It's better to have an intermediate appliance or something. It's cheaper. You have control of that. But again, it's a really nice feature, really amazing feature when we talk about security and we talk about controlling the backend traffic that lands into the virtual machines. Okay? This, my friends, is our first module of the day. As you can see, we took an hour and a half. So it's actually quite extensive. Again, as I said, we will have taken 2 hours, 3 hours just to cover this module in a full experience class. But again, it's the idea is that well, you can take a look on the key services, on the key concepts, and then we'll prepare with the study and the design. We have a pretty amazing case study. This is the most complicated one. Okay, so I'm not gonna click next because if I click next, you'll see the solution. But I think this is the most compelling exercise of the week because of all the services you can put together. I'm just gonna give you a tip. You're gonna use a VPN gateway, a balancer, a network security group, or application security group, a network, an application gateway, a network security group again, an express route, a firewall, and a web application firewall. You're gonna use 9 or 10 resources on this diagram. Remember, tomorrow I'm sharing the solutions. Okay, again, sorry, I know I said that today, but I was told by Microsoft to share all the extra contents during the exam prep session. That's the one that will take place tomorrow. Okay, so let me wrap up this one. And we're gonna go here to business continuity story. This is the last lesson of the week. And it's actually quite brief because it's one single service. We have backups and we have the backups for other solutions. So it's pretty straightforward. But let's see what we have in here. We're going to talk about backups, the whole backup service. Then we will see how to backup storage accounts. That's another topic. And we will see a little bit about SQL and recovery. So this is actually a short, interesting option. So let's do it here. First of all, you need to ask yourself these questions. Okay? We have to understand what we want to have, okay? What we want to protect. And it's pretty important that we have pretty clear about the recovery metrics, the objectives. The recovery point objective and the recovery time objective, RTO and RPO, are pretty important. Based on those two, actually, you'll be able to answer the other questions. An example. In the bank, we had two completely different scenarios. We had a recovery time objective of 30 minutes for the call center. We couldn't be without a call center, a contact center. But we have a recovery point objective of 24 hours. We knew that the chances of getting a call from a customer who already called before those 24 hours was less than 10%. So as long as we had the last day of calls, we will be covered by 90% of the possible recalls. So you can see, it's a pretty short time objective, but also a pretty short point objective. On the other hand, we had a recovery time objective for business users, let's say marketing, sales, corporate affairs, of 24 hours. If something failed, we were like allowing to have a complete day of no work, but we needed the last 30 days. I'm just giving you this example for you to catch the idea. Okay, I can live without marketing for a day, but they cannot live without the information of the last month. I cannot live without call center for more than 30 minutes, but they can live with one single day of information. Ask these questions, folks. when we are designing for continuity. We have a service called the Azure Backup, the recovery service vault. This is a dedicated service that will let you back up cloud to cloud, on-premises to cloud. Okay? The recovery service vault will actually let you have physical devices, Hyper-V, VMware, vSphere, third-party clouds, AWS, EC2, or virtual machines in GCP, backed up into Azure. And you can use the complete process we have seen of storage, security, connectivity, network management, authentication, authorization on the backups. You can put them on a storage account, you can put them on the backup vault, you can create copies in both. The idea is that we understand that all the things we have seen up to this point can actually be put together to keep our business running. You can keep the data, hypothetically speaking, forever. I mean, I don't know what will happen with Azure in 100 years, but hypothetically speaking, you can keep the data for an undetermined amount of time. You can keep as many copies as you want. Get a backup every 24 hours and keep the last 30 backups available. So these are options that we have on the backup vault. We can actually go and select how to focus. It's important that we remember, we have to focus on the requirements of the business, not on the technology. Okay? We have to see what the business needs, and then we will determine what technology or what features to use, right? So this is the idea of a backup. I mean, like the focus on the backup service. Let's remember something. The blobs, remember the blobs, the one we created on Tuesday, where we were seeing how the storage account worked? The blobs, folks, have an automatic option of retention. Remember when I was creating the storage account that I shown that we were able to have a versioning and a soft delete? It is important that we consider that the blobs cannot be backed up by the recovery service vault, only the file shares. Okay? If I create a service vault and I connect to a storage account, the only thing I can back up is the file share, not the blob. There are two options to back up a blob. This is the first one. We can actually, we can have a soft delete or a versioning with a long-term retention period. The thing with this one, folks, is that it only works in the same storage account. This means that if the storage account gets compromised, my versions and my soft delete retention will also be compromised, right? So this is the option one. The option two is to have a restoration or a backup in a secondary storage account. This is one of the best options I've seen for blobs. You can do this manually. You can automate this using automation accounts. The idea is that if I need to back up something beyond the storage account existence, that means another region, right? For example, one in the UK, one in the US, I have to configure a policy to back up every once in a while, every day, every week, every month, and have it ready in case of an actual failure of my storage solution. This type of backup, folks, this type of option, you can see here, let's go to the storage account for a second so you see. If I go here to my storage account and I select the container we created on Tuesday, you can see here, there is no, I have no access. I'm using a dynamic public IP. And if you remember, I grant the access to the IP I had on Tuesday. So I have to add my, you can see security in action. I have to add the new IP I have. That's the endpoint and the private endpoint. Whenever you want, there it is. I can go here, back to the container. So if I open one of these blobs, I don't have an option to backup, you see. I can create my retention policies we mentioned, the time retentions, the legal holds, but I cannot actually back it up here. I need to create a process to read the content, duplicate it, or move it, or copy it, or whatever we decide to do into a new location. The recommendation is copy asynchronously, obviously, maybe a couple of times per day, once per week. I don't know, whatever needs, whatever the business needs. It's actually the recommendation. But this has no option to back up automatically, on contrary of the Azure files. That is also part of the storage account. The Azure files can actually be backed up into a recovery service. I know this is I don't know how to say it without sound rude, but I think this is a weird decision of not being allowed to back up a blob the same way you back up a file share. At the end of the day, we can keep them both back up with different options, right? But it is important we consider this difference. Check this out. If I go to the file share, remember we can create a snapshot, right? I can go here. I can create a snapshot, and I can also enable the backup. These will back up into the service vault. You can see recovery service vault. This is the name of the vault. How often this will happen? You can see here the policy. Every day, 7:30 p.m., or every hour, like let's say every 6 hours for backups a day. You can see I'm gonna retain this for 5 days, so I'll have, at the end, I'll have 20 backups available, and I can select here if I want to have extended retention. That's the option of the backup. Something we don't have developed, we can do it like this. The recovery service vault will be created, will store my backups, and then I'll be able to restore from it. Again, folks, for the exam, the storage account itself is not backed up, okay? It's only the file share. Whatever else you have on the storage account has to be replicated manually using policies or using automation accounts, okay? Another option we have to back up on the same recovery service vault that we have here are the virtual machines. We can do exactly the same that I was doing with the file share. I can grab a virtual machine, I can enable the backup, and I can send the information into a recovery service vault every specific amount of time, keep as many copies as I want, keep them for as long as I need, and then refer to the service vault to replicate, to recover from it. Okay, check this out. I can go back to the virtual machine. I can scroll all the way down here, backup, and the same, you see, a new vault. You can see here what type of policy. You can see one backup per day, 1 to 5 days of operational tier. Its vault is, the backup is not distributed in zones. If I use this one, folks, the backup that I'm getting from this also has copies. So I can have a copy of the backup distributed in different zones. Remember the zones? Remember I explained some regions have multiple data centers. So my backup will be in another region, and that region will have 2 or 3 copies distributed in different buildings of the same region. So obviously this is good, right? This is a good call. I'm not saying that this is like the best option or the only option you should follow. A single backup might be enough, right? A single small backup might be all we need once per day in the same region, and that's all. But hey, at least we know that we have the option. You can select here the policy. You can see here every hour. Let's put 2 backups per day. I'm gonna keep this for how long? 5 days, 1 day. How long would you like to have the backups? Let's have 10 copies, 5 days. And I'm going to retain here for 15 days. There. So you can see, well, I can add here a backup group, just like a tag. You can see, folks, the recovery service vault is specialized on these 2 workloads, the virtual machines and the file shares. Inside of a virtual machine, you might have SAP, you might have HANA, you might have SQL, you might have Oracle, you might have a lot of things. Well, those workloads are also protected by the recovery service vault. But these are the only two services that can be backed up by the service vault: the file shares and the virtual machines. If you want to back up, as we saw, the queues, if you want to back up the tables, if you want to back up the blobs, you have to manually replicate or automatically replicate. If you want to back up SQL, SQL uses a dedicated backup service. Question for the exam. Okay? We have the service vault for virtual machines and file shares. We have the replication for blobs and the soft delete retention for blobs. And SQL, folks, uses an automatic backup and the option of a manual backup. Take a look at the screen. We have a full backup every week. Differential backups actually it's once per day. It says sometimes twice, but it's by default is once per day. And we have transactional log backups every 10 minutes. It says 5, but usually goes for the 10. This is done by default in managed instances. If you create a SQL service with a managed instance, that means platform as a service, not SQL inside of a virtual machine. This is granted to you. You have this by default. You can create your own backup if you want. You can manually determine how often that the backups will take place in your SQL database. But remember this for the exam. By default, this is in place. Okay? Some considerations, folks. If you go for one of these backups, well, if you decide to bring back one of these backups, by default, you only have 35 days. Okay? You can enable, with an extra cost, the long-term retention that goes up to 10 years. Okay? The longer you retain it, the cheaper per day, actually. So it's an economy of scale. But it's actually a thing that we have to consider. The backup might actually take a while there to be visible. You can restore the database from during that retention period to any point in time that is available on your logs. You can restore the database on the same location or to a different location and have now two databases. Okay? And remember, you can have read access to the long-term backups. You can read from the backup directly if you need to. Why is this last point important? Because all the other backups we have mentioned are not read only. You can only bring them to restoration. These backups can actually be monitored by you with a read-only multi-regional location. This is the only service from all the other backups that has this, let's say, ability or capability. Sorry. So it's a recommendation. It's a recommendation that we plan independently for the SQL compared with the other stuff. Because it's done automatically. It's more about what use will have for us the list of benefits we have seen in here, right? From the things that we can get from SQL, what will you use, what will you find useful, and what will not be used at all or should be disregarded as existing but not needed, right? That's the idea of this backup. And these are the different backups we have. So let's summarize. We have the blobs with a manual replication or with versioning and self-delete retention policies. We have the file share and the virtual machines with the recovery service vault. We have snapshots for both if we want to have snapshots. We have the SQL that has an automatic backup in managed instances with full backups every week, as we saw, with differential backups once or twice per day, and with transaction log backups every 5 to 10 minutes. Those are the 5 key points of the backups. There is a mosquito here. That's one of the contrasts of teaching during the mornings. Okay, so these folks are the considerations of the backups. Now, all this is to keep our backups ready. We need to design, knowing this, focusing on a disaster recovery, right? How are we going to use those backups in case of a disaster? What is the plan? In case of a disaster, folks, Remember, the same recovery service Vault offers an Azure site recovery. Mexico, Nilanjan, I'm teaching from Mexico. It's 4:51 a.m. So this specific part, folks, the site recovery, is offered by default by the same recovery service Vault. That's a good thing. We have the backups on the service Vault. Remember, we have the backups of the file shares and the computers. Important, the backups of the computers are actually done over the disks, plus a template configuration for any change done to the virtual machine. When we want to go for a disaster recovery, on-premises to cloud or cloud to cloud, because any of both options might be a thing, remember that it will always go for a secondary region. That's actually what I was going to mention. The backup can be on the same region. Eder is asking, should I or do I need to backup in a different region? Best practice, yes. Design principle, yes. Okay, but it's not a mandatory thing in Azure. Obviously, if you want to increase the SLA, reduce the time of recovery, and in case of a region failure, be protected, the best practice is to have the backup in a different region. Okay, so one of the ideas of the site recovery is that we go from region A, backup in region B, and maybe recovery in region C. That's a usual recommendation. Or for example, location, physical location, office, backup into Azure region 1 and deploy into Azure region 2 in case of a disaster. Again, it's not like you should always be for or follow the same instructions I'm giving or the best practices I'm suggesting, but it's a good option. Obviously increases the cost because you use a multi-regional deployment. You have to pay for storage in region 1 and region 2, deployment in region 3. But if we're going to follow the best practices of design, the disaster recovery should follow the multi-regional approach. Okay, we can use, as I was mentioning, the recovery service Vault to replicate and then drop the location into a new region. If there are issues, for example, like network or power outages, you can use the recovery service Vault to read from it or to deploy from it into region 2, into region 3. Keep in mind that the initial backup, and this goes based on Eder's question, the Azure backup for the virtual machine will be on the same region by default. The disaster recovery will be required to be sent to a different region. This means, and this is for the exam, that if you combine the recovery service Vault and the disaster recovery, you can live with 2 regions or 3 regions. Virtual machine and backups in region 1, recovery service or disaster recovery in region 2. Backup in region 1, disaster recovery in region 2, computer in region 3. Computer in region 1, disaster recovery and backup in region 2. So again, I don't want to get you confused because of all these options. The usual option is backup and virtual machine region 1, recovery service in region 2. Okay, so the recommendation is consider obviously sovereignty, data residency, I don't know, all the conditions of compliance and governance that might affect your country location. So it's one of those things that you have to include in your plans. Okay, so as I said, this was a short one. We're almost done. We have 5 minutes. This specific practice, folks, will follow this list of like options. Okay, your activity in this one is to suggest a disaster recovery method based on a decision tree. So just as an FYI, we are also going to have a solution design in here, but we are going to recommend based on these considerations. You have virtual machines, production workloads, we need to back up. We have Linux virtual machines that we need to back up. We need to have a disaster scenario. What service will you use? We need a read-only full copy of disks. What will you use? You need a backup to manage disks. What will you use? So the idea here is like, okay, based on the requirements of the customer, what will you suggest? More than an actual diagram solution like the others, is about what service could you use for this or that. this is the practice of the last module. Okay? We have completed our theory, folks. We're done with our theory of the week, actually. So it has been a pleasure. Let me just move this one back here so I can see you. There, I can see you. So I don't know if you have any questions, folks. Let me stop the screen so we don't get there confused. Any questions, any issues, any complaints, anything that you may want to discuss, anything extra? We still have a couple of minutes. Tomorrow, folks, will be a little bit shorter. I'm going to try to go for the 2 hours, but again, it's a summary of the week and tips for the exam. So tomorrow's session is the exam prep. I'll be sharing tomorrow as I said, the materials, a small OneDrive link where you will be able to find the solutions, and also some extra videos and white papers I put together for you. So you can have a little bit more content to grasp on the knowledge, because I know we're only having 2 hours per day instead of the usual 8 hours. You have to do the homework, so it feels a little bit harder than an actual live session, right? Like a class. So that's just for you to be ready. Okay, a read-only backup supposed to be copied into a writable version. No, Ahmadu. Actually, you could if you want, but it's not a mandatory thing. Okay, you can do it if you need to create a writable version or create a readable and writable version in a different location. But by default, keeping the read-only, it's enough, and it's a best practice. My friends, we have 1 minute. Yes, we have now 2 minutes left. I don't know if there is any other question that you might want to talk about or discuss. Let me know. We're going to wrap up our last day of theory. We will be back tomorrow, as I said, 2 hours of the exam prep, the extra materials, the end of class materials, the survey. And remember, you have to be here tomorrow too to be to be granted with one of the vouchers of the week. Okay? We have 3,500 vouchers for this week, but that includes all the different tracks. So if you met all the requirements, for sure, you might be here. Okay, I'll talk about that tomorrow, Peter. But there might be a couple of ATS in there. Okay, so I don't have that actually, Dilanjan. There are no dumps we can share. So I'll talk about the end of class activities tomorrow. Peter and Said, you are asking about the badge and stuff. I'll mention that tomorrow. You have to be on the class tomorrow to be eligible. Okay, so that's an important one. We have 50 seconds left, but it's important you're here tomorrow so you can get the badge, you be eligible for the voucher, and I'll be sure to give you all the tips and tricks about the exam and the after class activities. Okay, so we're gonna stop the live session now. We're gonna take the question that we have on the inbox and we will answer it. Don't worry, we'll still have the answers. But I'll see you tomorrow morning, folks. I hope to see you tomorrow, all of you, and we will get here for the last day of class. Thank you very much, my friends. Have a great day. I'll see you tomorrow.